lesson on naming chemicals. If it's an ionic compound, ionic compounds start with a metal, which are on the left-hand side of the periodic table, and a non-metal or an anion, polyatomic ion. Anions have a negative charge. Metals are cations, which are positive charge. So the positive and negative charges have to cancel out, but if they're named, if they already have a formula, you already have that. So the cation and an anion, you can also have non-metal or polyatomic ions in both of these. There's many more than the 7 polyatomic ions that you have to memorize. These will be on the homework on page 44 in your textbook. These are fair game for homework because you'll have access to the table on page 44. But on quizzes and tests, only the 7 polyatomic ions you will be responsible for knowing. So if it's, say, Ag3PO4, name the compound. Ag is silver, PO4 is phosphate. If it has one set charge, you do not need Roman numerals. If it was MnPO4, Mn is manganese. Manganese does not have a set charge on the periodic table. PO4 is phosphate. There's one phosphate group times 3 minus. That means this is 3 plus divided by 1 is 3. So it's manganese 3 phosphate. You can have polyatomic ions that are not on the periodic table. NaHCO3. That's not one of those that you memorized. So you look up Na, which is a metal, so that's sodium. It has one set charge. And then you look up HCO3 on page 44. And I prefer hydrogen carbonate. It makes more sense than trying to find out bicarbonate. Bicarbonate is the older style of doing it. Hydrogen carbonate is really easier because it's hydrogen stuck onto a carbonate. Bicarbonate, you just got more things to memorize. So I would go for that. Again, you don't have to memorize that, but in AP Chem or to go on to other chemistry classes, you might have to do that. So that's a brief rundown on how you name ionic. Covalent compounds, this is new. On a covalent compound, you use prefixes. These are on page 46. CO2, C and O are both negatively charged. So if you do CO2, you can't get the positives and negatives to cancel out. So it's not an ionic, it's covalent. It's a different type of bond between the carbon and oxygen. So what you do is you name it by how many there are. Carbon, you never, prefix for one is mono, but you never start with mono, Te. Carbon, and then you look at the O2 part, how many oxygens? 2, so that's di, and then they always end with oxygen, they always end with ide, so it's oxide, so it's carbon dioxide. P2O, or P2S5. There are 2 phosphorus, even though it's 3 minus, we don't do that. So it's diphosphorus. 5. Now you look at the sulfur. 5 is pent. S is sulfur, but we make it sulfide. Again, it will always end with ides, and you just have prefixes in front. So, and you know you do the prefixes because the first thing here, carbon, phosphorus, is not a metal. The non-metals are on this part of the periodic table. The metals is everything else. So it's up here, starting with same boron, and on down to radon. These things are the nonmetals, and if it starts with one of these, then you use the prefixes. If it starts over here, then you use the ionic compounds. There are two exceptions to this. H2O is never dihydrogen monoxide. There's a story on that. This is known as water. The reason is we knew water before, but we didn't know what the formula was, so we stuck with it. The other exception is NH3. NH3 is not nitrogen trihydride, it is ammonia. It's not a polyatomic ion, so it doesn't end with So this is ammonia, because it ends with 3. Remember, NH4 plus is ammonium. So these are the two exceptions where we use the common name rather than the scientific name. That ends this lesson on chemicals.